Let's see what we have to do in part A. Part A is preparation of aggregates for asphalt mix design specimen. So we have to prepare 1,200 grams of an asphalt mix. In this mix, we should have 60 grams of bitumen and 1,140 grams of aggregates. This 1,140 grams of aggregates are in different sizes. And now in the part A, we are going to select aggregates from different sizes and make this mix. So here they have given us the gradation, the grading envelope, and also here we have the retained based on grading target percentage. So this is the percentage. If we are making 100 grams of aggregate, this is the amount that we have to take from each size. So here you can see the aggregate sizes: 90 millimeters, 13.2, 9.5 millimeters, 6.7. So you can see the aggregate sizes in this column. And in the second column, it says the percentage target. That means if you are making 100 grams of aggregate, from each of this size, we have to take this much. So 17 grams from 9.5, 15 grams from 6.7, 11 grams from 4.75. But we are not making 100 grams, we are making 1,140 grams. So we should be able to do the calculation and find out how much from each size that we need to prepare the 1,140 grams of an aggregate mix. Let's see how we'll do the calculations. So as I told you, we are doing the calculations only for the 5%, and you can follow the same steps and do the calculations for the other percentages. Okay, now this 1200 times 0.95 is our 1,140. So if this, to make this 1,140 from the size 19 millimeters, we have to take 1,140 times this much, 0%. So if we find that, that will be our first one. From 13.2 millimeters, we have to take 5% of that. So to make 1,140, we take 5% of that. And that number will come here. To make this 1,140, we need 15% of 2.36 size. So that means 1,140 times 15% from this. So you can find out how much of 2.36 aggregates that we need. Likewise, do the calculations for all the sizes, and when you add all these aggregates, you should get 1,140, because that is what the total amount of the aggregates that we need. So I did my calculations and this is what I got. And when I add all the numbers, I got 1,140. That means my calculations are right. And in the next column, I have mass passing. This is the amount retained in each sieve. So that means when you take this 1,140 grams of aggregates, the mix of the aggregates, and we do the sieve analysis. So this is the sieve fraction. That means sieve analysis is, in sieve analysis, you have a set of sieves in different mesh sizes. You have a bigger mesh at the top and smaller meshes at the end. And when you put your aggregate, the mix of the aggregates in the sieve analysis, and when you shake the sieve set, you can see different sizes are remaining in each of the sieve. So these numbers that you got here are the amount retained in each sieve, the mass retained. If you want to find the amount passed through, that means when you put 1,140 grams, this much remained in this sieve, the rest went through. So you need to find out how much went through this sieve. So how do we find that? So you have 1,140, only 0 remained in the first sieve. So if you minus that, the rest went through. If you go to the second one, you have 1,140 total, 57 retained in the sieve, the rest went through. So the 57 minus 57 is your next mass passing. If you go to the third one, that will be 1,140 minus all of these didn't go through, they remained in the top sieves. The rest went through, so you have to minus all of this. So that is 57 plus 193.8. When you go to this one, that will be 1,140 minus all of the above amounts remaining in the top sieves, the rest only went through. So you minus all of this. So 57 plus 193.8 plus 171 plus 125.4. So likewise, do the calculations and find out the amount passed through. So when I did my calculations, this is what I got. So there is an easy way to do this. When you find this, you minus this from this, then it will be easier for you to do the calculation. So 1,140 minus 57 is this. 1,083 minus this will be that. 889.2 minus this is this. So you can do the calculation in an easy way and do the calculations for 4% and 6%. And in the next column, we need to find the percentage passing, which is the grading. So percentage passing, this is the mass passing. In the next column, how do we find the percentage passing? So we have a total of 1,140. So 1,140, out of this 1,140, 1,140 passed through. So the percentage is what? 100%. So you can find that. So if I want to find the percentage passing for this, that will be out of 1,140, only 592.8 passed through. So percentage. So likewise, you find the percentage passing. So when you go to this, that will be 57 over 1,140 times 100. So I did my calculation. So this is what I got. So these are the percentage passing from each of these sieve sizes. We need to find this because we have to plot a graph, the grading graph. So in the next slide, I have the grading graph. If you see this grading graph, the y-axis of the grading graph is the percentage passing, which we found here. So this is the y-axis. And in the x-axis, what do I have? I have the sieve size in the x-axis. So if you go here, I have this is my x-axis. So you know the x-axis and the y-axis. So you can plot this on the graph. So for example, 4.75 is here. And the percentage passing is 4.75. For 4.75, the percentage passing is 52%. So you find the 52 here, somewhere here. So you can plot this. Likewise, you plot all the points and you get a graph like this. You need to plot this graph for all three percentages plus the grading envelope. When you plot the graph for the grading envelope, you have a minimum and a maximum. So it has two lines like this. And your target or else whatever you found here should go in between this. Otherwise, you can't use this amounts of different sizes. So this graph, you have to plot in the chart. You can use Excel to do that. I use Excel to do the graph and this is what I got. And also there is another table for you to plot, fill in part A. In this, you need to find out the amount of coarse aggregate, fine aggregate, and the filler, and also the bitumen. Coarse aggregates are the aggregates size above 4.75. So this is coarse. And the fine aggregates are the aggregates up to here. So this is fine. And the pan is the filler. To find how much of coarse aggregate that you have in the mix, you just add the total mass. So you add all these numbers together. So you can find the amount of coarse aggregate in your asphalt mix. So you write this answer in this point because we are doing for 5%. And to find the amount of fine aggregates, you just add all these numbers together, all the weights, mass, then you plot that one here. Just write the number there. Filler is this. So this is 57. And the bitumen content, you know how much of bitumen we are adding. We are adding 60 grams of bitumen. When you add all these together, you should get 1,200, which is our total mass of our asphalt mix. Here you have the masses, and in this part, in the left-hand side, you have to find the percentages. You know how to find the percentage. So 60%, 60 grams out of 1,200 times 100%. And this one should be 57 divided by 1,200 times 100%. You do the same thing for the other two. When you add all together, you should get the 100%. So fill this column for all three percentages. And in the lab, we can find aggregates with different sizes. So as you see here, in the lab, we find different sizes aggregates. And we are going to weigh the aggregates in different sizes and weigh in these amounts. And we are going to prepare this 1,140 grams of aggregates with different sizes. Let's go and see how we'll do this in the lab. Yeah, let's start with the part one. And as you see here, we have different sizes in aggregates. So we have 13.2, this is 9.5, this is 6.7, 9.7, 4.75. So we have different sizes. Now, so we have done the calculations from each of these size, how much aggregates that we need. So now we are going to measure these amounts and we are going to make the mix of the aggregates. Let's start with the pan. And with the pan, we need to have 57 grams of the aggregates or the filler. So I'm going to measure it. So we will make this 0. And we'll measure 57 grams from this. And we're going to make the mix in this container. So I'm emptying it here. Then the next one is with the 0.075 millimeters. Again, from that one we need another 57 grams. So I'll take that one and we'll measure 57 grams from that. So we'll make the 0. Then the next size is 0.150. So from that also we need 57 grams. So 0.15. The next one is 0.3 millimeters. We need another 57 grams from that. So 0.6 millimeters. From the 0.6 we need 79.8 grams. So that calculations we did before. So it's 79. 79.8 almost. Now the next size is 1.18 millimeters. We need to have 114 grams of that. So it's 1.18 and 114. Next size is 2.36. So we have 2.36 here. And we need to have 171 grams of 2.36. 171 grams. The next size is 4.75. So we need to have 125.4 grams from that one. One 125.4. next size is 6.7. So we take the 6.7 and we measure 171 grams from the 6.7. The next one is 9.5 millimeters, and we need to have 193.8 from that. Our last size is 13.3, and we don't have anything from 19, it's 0. So our last one is 13.2. This is 13.2, and we need to have 57 grams of that. So we have prepared the aggregate mix for the 5%. So this is the aggregate mix for the 5%, and the procedure will be the same for 4% and 6%. And you can do the calculations, and we normally do all three percentages in the physical class, but for today's demonstration we only do for the 5%. Now we have to add 60 grams of bitumen. So this is hot bitumen, and we are going to add 60 grams of the bitumen, and we are going to mix in the mixture. When we add the 60 grams, your aggregate mix will look like this. Now it's hot, and we are going to use this to compact and get this, the cylindrical specimen for the other tests.